Welcome back, Focus Learners, to another explainer. Today, we're targeting a super specific, highly technical challenge that, honestly, if you're a power user, you've absolutely faced this. We're talking about keeping your local Codex environment running at absolute top speed. If you've been, running parallel coding workflows, spinning up multiple work trees, keeping complex chats going, you know exactly how crucial a snappy UI is to your momentum. So we're going to unpack exactly how the new keep-codex-fast skill drastically reduces that local drag. It cleans up your environment, and it does the whole shebang without ever risking your valuable context. Okay, let's dive into this. Picture this. You've had a ridiculously productive month. You're successfully multitasking across all these different repositories. But then, it happens. You know the feeling. Navigating between threads starts to stutter. Just opening the app feels, heavier. You're experiencing the dreaded UI drag. And it's incredibly frustrating, especially when you really rely on Codex to move fast. But here's the thing. It's actually not a bug. It's really more of what we might call the pain of success. So, here is our roadmap for today. We are going to quickly cover why Codex slows down, enter keep-codex-fast, the 3 operating modes, the handoff workflow, fixing metadata bloat, and finally, best practices for maintenance. Let's jump right in. Section 1, Why Codex Slows Down. Let's look under the hood for a second and see what's actually piling up on your local machine after weeks of heavy developer use. So, the hidden culprits of local drag are, ironically, just the artifacts of your own productivity. When you use Codex heavily, steat just naturally accumulates, right? Because the system isn't self-cleaning. You end up with these stale Git work trees that were super useful like 3 sprints ago, but now they're just sitting there taking up space. You've got massive log files like those logs_2.SQLite files that have rotated way past the point of being useful. Your config file? It might be totally clogged with dead project references pointing to repos you deleted ages ago. And of course, you've probably got dozens of old, really heavy chat sessions just piling up in your active thread list. Now, what's really fascinating here is that the biggest performance killer isn't even the overall size of your codebase. It's actually SQLite metadata bloat. See, certain Codex desktop builds take the entire text of your very first user message, and they cram it into both the thread title and the thread preview fields. So if you paste a massive block of code or a giant stack trace to kick off a chat, those 2 database fields can literally balloon to hundreds of thousands of characters. And because the threadless navigation has to read those fields before the UI even renders a conversation, well, that metadata bloat causes massive sluggishness right when you're just trying to click between chats. Which brings us to Section 2. Enter keep-codex-fast. This is basically the ultimate, perfectly safe solution for clearing out all that local environment bloat. Before this skill came along, developers usually had to rely on these risky, traditional delete-all scripts to clear out their environments. And honestly, that's a terrifying prospect when your active chats are holding vital context, unmerged code, and all your open architectural decisions. But the keep-codex-fast skill? It introduces a totally different paradigm. It's calm, it's read-only by default, and it heavily prioritizes backups. It completely replaces that sheer anxiety of deletion with the absolute safety of archiving. And this quote right here, this is the absolute guiding principle of the tool. Read it, remember it. Make handoffs first. Archive, don't delete. Apply changes only when you are ready. The tool operates on this strict, unwavering rule that your continuity as a developer matters way more than saving a few megabytes on your hard drive. Moving right along to Section 3, let's explore exactly how this tool executes that philosophy through its 3 operating modes. So the skill gives you total control through these 3 modes. By default, it always runs in inspect mode, which is purely a read-only report. Then, when you're actually ready, you can switch to maintain mode. This one actively backs up your config, archives old sessions and work trees, rotates those giant logs, and prunes out dead paths. And finally, there's an optional repair mode. This one is specifically designed to surgically trim down that bloated SQLite metadata we were just talking about. And this brilliantly illustrates the safety-first design. Inspect mode is never, ever going to surprise you. It doesn't write files, it doesn't move folders, it just simply diagnoses the weight of your logs, flags heavy background node processes, and counts the character size of your active sessions. It gives you the full picture, plain and simple, so you can decide what your next move is. All right, Section 4, the handoff workflow. This is the core operational philosophy of keep-codex-fast. It's exactly how you preserve your context before you ever archive a single thing. Let's see how this builds into a very strict, highly recommended sequence. You never just jump straight to applying maintenance. Step 1 is always inspecting your state. Step 2, and listen, this is the most critical part, is creating handoffs for any active, heavy chats that you still care about. Only after you've captured that vital context do you move on to step 3, applying the maintenance to actually move those heavy chats into an archive. Think of a handoff document kind of like passing the baton in a relay race. Before you archive a massive, sluggish session, you ask Codex to just generate a concise markdown file right in your repo. This document captures your current goal, the files you've touched, the commands you've already run, and any open decisions. But crucially, it includes a reactivation prompt. This is a short block of text you can just copy and paste into a brand new lightning-fast Codex thread. It instantly catches the AI up to speed without dragging along the entire bloated history of the old chat. So the crucial point is this mental model right here. Chats are for execution. They're your short-term working memory. Handoff docs are for your durable project memory. Once you really adopt this workflow, you can confidently archive those heavy, bogged-down execution environments because you know your project memory is safely tucked away in a clean text file. It's just sitting there, ready to spark a fresh, fast thread whenever you need it. Let's transition over to Section 5, Fixing Metadata Bloat. We are getting back into the technical weeds of SQLite here to address the absolute most insidious form of Codex sluggishness. I want you to imagine scrolling through your chat list and out of nowhere, the UI just totally freezes up. Why? Because the system is trying to read a single thread preview field that is literally 340,000 characters long. And no, that's not theoretical. That's a real-world example from the source data. It happens when you paste a massive log file into the very first prompt of a new session. I mean, no wonder the app starts dragging. To fix this, keep-codex-fast offers this really smart optional repair flag. It's strictly opt-in because it does directly edit the database display values, but when you apply it, it safely trims your active chat titles down to 120 characters and the previews down to 240. But here's the absolute best part. Your actual conversation transcript, like the full JSON-L rollout file, it remains completely intact. It only shrinks the display layer. So it instantly restores your navigation speed, but you don't lose a single line of your actual chat history. Which brings us to our final stop, Section 6, Best Practices for Maintenance. Let's talk about how heavy users can safely weave this skill into their long-term, day-to-day workflow. Now, you might be super tempted to just set up a cron job to automatically run the maintenance every Friday afternoon. Don't do it. Seriously, automated maintenance should only ever be a read-only reminder. Why? Because an automated script cannot possibly know if you've remembered to create handoff docs for the chats you actually still care about. An automated apply risks blindly archiving vital context that you really meant to keep active. So, stick to automated reminders and only manual applications. To quickly summarize the critical safety rules here, always close Codex completely before applying changes. That prevents nasty database locks. Also, remember that the backup folders created by this tool, especially files like thread metadata repairs.jsonl, contain your raw local metadata and prompt histories. So keep them private on your local machine. Don't go uploading them to public repos. Always use handoffs for important threads. And if you're a real heavy power user, just run an inspect report weekly to keep an eye on your local state. Which leaves us with this final, kind of provocative thought. You rely on AI tools to accelerate your workflow, right? But if you don't actively manage your local state, the sheer weight of your past work is quite literally going to slow down your current execution. So, are your old bloated chats holding your future projects back? By adopting this handoff-first, archive-driven approach with keep-codex-fast, you can ensure your environment stays just as sharp and responsive as the day you first installed it. Thanks so much for joining me on this explainer, and I'll catch you in the next one.